All right, so 6.1, applications of right triangles. Now, applications typically means word problems. However, I've taken out the word problem part of this because we're kind of going down to those bare basics we need going forward. So really, this section is about solving right triangles. So solving a right triangle. Solving a right triangle means that you find all of the triangle's side lengths and all of its angles. That's all that it means. I will write that down. So all the angles and all of the side lengths. So let's go ahead and do an example. All right, so here we have a right triangle. We're asked to solve the right triangle and round your answer to the nearest tenth. I wrote this directly off of Alex. So quickly, rounding to the nearest tenth, that's 1 decimal place. All right, so looking at this triangle, we have one side length that we're given, and it looks like we're only given one angle, but you're actually given 2 angles because there's a right angle right here, and right angles are 90 degrees. So what we're left to find are the remaining angle and then the 2 side lengths. And Alex is going to ask for each of them. The, I think, most straightforward one to start with is this angle up here, angle B. There are 180 degrees in a triangle. 90 of those degrees are taking place down here, and then there's 40 degrees right there, and whatever's left over, that's what angle B has to be. So angle B is 50 degrees. 180 minus 90 minus 40. So angle B equals 50 degrees. Go ahead and write it, box it, we're good. So we found angle B. Let's then go and try to find side lengths A and side lengths B. Let's use, I don't know, this like tealy color here. You can start with whatever side length you want to start with, but I'm going to go ahead and start with side length A. So I'm going to use the angle that was given to us, this 40-degree angle, and I'm going to set up a trig ratio that makes sense. So I want to solve for A, and a trig ratio needs to include 2 of the sides and an angle. So I can use this angle 40 degrees, but if I try to use sides A and B, I don't know what B is and I don't know what A is. So I can't use A and B together. If I want to solve for A, I'm going to have to use the side length I know, which is this guy over here, the hypotenuse. I know that the hypotenuse is 23 degrees. So looking at for angle 40, for 40-degree angle, his opposite side is A. So 40 degrees, his opposite side is A. And his hypotenuse is 23. So if we have opposite and hypotenuse all together, that's opposite and hypotenuse. So if you think of SOHCAHTOA, that's sine. Sine uses opposite and hypotenuse. So sine of 40 degrees is equal to opposite over hypotenuse. So A over 23. I want to get the A by itself, so I can multiply both sides here by 23. And cancels the 23. So A is equal to 23 sine of 40 degrees. I need to grab a calculator real quick. I'm going to go do that. All right, so I got my calculator out. Make sure your calculator is in degree mode. If your calculator is in radian mode, you're not going to get the right answer. So my calculator is in degree mode. I put 23 sine 40 into my calculator and rounding to the first decimal place. So let me tell you what it gave me. It gave me 14.78 411,502. That's what shows up on my screen. But I want to round this to the first decimal place. So because the second number, the second decimal place, is greater than 5, I round the 7 up. So side length A is approximately 14.8. We're going to go ahead and do the same thing for side length B. So let's look at, what color should we use? We'll use purple. Purple's a nice color. And erase those dots I just made. Scrolling down, so here we'll talk about side B. Let's make that a wavy underline. So still looking at that 40-degree angle, right, this 40-degree angle. Now B, we want to use B and 23. So B is the adjacent side, and the hypotenuse is 23. With SOHCAHTOA, if you have adjacent and hypotenuse, that's going to be cosine. So cosine of 40 degrees is equal to adjacent, which is B, over hypotenuse, which is 23. Using the same math that we did before, you're going to get B is equal to 23 cosine of 40 degrees. And plugging that into my calculator as we speak, I get 17.61, which rounds to 17.6. So up here, B is equal to 17.6. And now we have it. We have all parts of the triangle. We were given 2 angles and a side, and we're coming away with the other angle and the other 2 side lengths. So that's that for this problem. Most of the problems are kind of similar to this, but there's that for you. So let's do a different one. All right, so let's look at this example. We're asked to find x and round our answer to the nearest tenth of a degree, which once again, that's 1 decimal place. And so we're not solving a right triangle here. We're just going to find x. We're given 2 side lengths of the triangle, and we're trying to find an angle. You might be tempted to say, oh, I can solve for this remaining side using the Pythagorean theorem, which you're not wrong, but that's going to be unnecessary in trying to figure out what x is. So in relation to x, we have an opposite side. So we have the opposite side, which is 17, and then we have the hypotenuse, which is 22. Ooh, that's a terrible 2, 22. Once again, using SOHCAHTOA, just like we did before. SOHCAHTOA, this is going to be sine. So we have that sine x is equal to opposite over hypotenuse. To get x by itself, we're going to take inverse sine on both sides. So the way this is going to look, we have sine inverse of sine x equals sine inverse of 17 over 22. Now, sine inverse and sine don't always cancel themselves out, but when we're talking about triangles, they will. So sine inverse cancels out the sine. And now we have x is equal to sine inverse of 17 over 22. So on your calculator, to get to the sine inverse button, you have to push the shift key first because there's a little yellow sine inverse above the sine key. So you'll click the sine inverse and then 17 divided by 22. Make sure your calculator's in degree mode because they're asking for a degree. So let me just write what the calculator says so we can talk about the rounding of it. So I'm looking at this number. I want to round to this decimal place here, right? The second number is greater than a 5, so we're rounding up. I know it's kind of weird to talk about rounding, but just it's worth it. I know there's some people who haven't done rounding in a while, so we'd round the 5 up to a 6 and put a degree symbol there. So 50.6 degrees is what x is. And that's all there is to it. So depending on what side lengths you're given, you would just use that appropriate sine, cosine, tangent, whichever one is needed. So if you're given opposite and adjacent, you would use tangent. If you were given adjacent and hypotenuse, you'd use cosine. So really, that's all there is to talk about from this section. There's really not much more to it than that. I mean, it's either going to be like this example or like this example back here where you're solving for an entire triangle. There's 3 topics in this section. One of the topics, so I did 2 problems. There's 3 topics. One of the other topics is it's exactly this problem here, but it only has you solving for one side length. So it's the same stuff. If you have any questions, please feel free to email me. I am here to help you out. You got this. Stay safe, stay healthy. Bye.